Hey, Gemma. How's it going? How you doing this fine evening? Hey. How are things? How was your weekend, Gemma? I'll go to the main cam here. Chatting. Camera. Thingy bob. Yeah. Hope you're doing good, Gemma. Doing alright? Good. Up late again? Gotta work tonight? Or tomorrow, I should say. This is almost midnight, but I don't know if you gotta work tomorrow or not. Hence, we gotta ask. Here we go. Change this. Doing okay. What'd you do this weekend, Gemma? I gotta ask. Hopefully you had a chance to relax, maybe spend time with the new boyfriend there. Busy because you're working all weekend. Oh, might be working tomorrow if you ask. Oh, I see. Manager could ask you to come in and just like work some more. There you go. I forgot, Gemma. I've totally blanked out. What was it? What was your job again? Really quick. I totally forgot. Why am I blanking out? You told me before, and I'm like forgetting what your job was. Oh, what? Already? Oh, you do waitressing. That's right. Wait, hang on a second. Already? You're already done with him? Oh, that's a shame. Sorry it didn't work out. You deserve somebody good, Gemma. So I have faith. I have faith that maybe the next guy will be a real lad. He'll be a really good guy. Yeah, you broke up with him? Yeah, you know what? Things like that are gonna happen if you did that, you know. It is what it is. But I'm sure you had your reasons to break up with him, so. I just hope again you find somebody that's gonna take care of you and treat you right. That's what it's about. Otherwise, they don't treat you right. Well, there are consequences for that. Consequences from many miles away. we're gonna have pseudo dad come down and be like, time to lay the smacketh down. we don't treat people like that. Man, what a chill day. Music's pretty chill too, I ain't gonna lie. Hopefully it'll be good for studying. It's gotta do some studying. Now, hang on a second there, Gemma. Hang on a second. Why would you say that about yourself? Hang on a second. You can't really believe that. Gemma, remember who you want to be. You want to be an actress. You know, and I believe, this is just coming from my own personal opinion, that you are beautiful inside and out, Gemma. You yourself have to believe that as well. Gemma, it's not easy to find the right person. Look at me. I haven't found the right person, and you know, I'm well over age here, but you know what? Those things happen. I happen to find beauty in other things. I may not be the like, for example, I may not be the best looking guy ever in the whole wide world. I understand that, but you know what? Beauty comes in a lot of different forms. But I think that you, Gemma, you're young. It's okay. You know, it's fine. Those things are going to happen. But you know what? You are beautiful inside and out. You got a good personality. You got good features. You know what? You got great. You got a great sense of humor. I respect that. You should respect that too about yourself. Plus, the guy that I like only sees me as a mate. Okay. So the guy only sees you as a mate. Alright. But that doesn't mean you should limit your choices as well. You know, be a better you. You know, if he only sees you as a mate, okay. He sees you as a friend. You've been friend zoned. Alright. It is what it is. But you go find another guy who may not see you as a mate, who may see you as a, you know, more than that, a romantic partner. You know, those things are going to happen. I beg to differ. You got pictures of cute dogs. I mean, if wearing the cone of shame. If that's not funny, I don't know what is. uh, Hey, Yosin, my friend. How you doing today? Hope you're doing absolutely fantastic. Good to see you again today. Just to let you know, we're doing some optimization today. So that's what's on the docket here for today. Get me some optimization. Got some problems mapped out here for today for once. See how it goes, right? Problem. That's not funny though, because that's what it's just the look on his face that was funny, Gemma. Come on. He was just like, I got the cone of shame. Oh. He was a poor little pupper. I know he had to go through major surgery. Trust me, I'm very sympathetic toward that. It was just the look on his face in the picture. He's like, oh. He couldn't help but feel bad and smile at the same time. Here to learn some calculus. Excellent. Hopefully you learn a little bit here today. That's the hopefully you do. Question mark, question mark, question mark. No, I'm pretty sure you will. Pretty sure you will. Look, Gemma, I think you're a fantastic person. 100%. Alright? Look, you just gotta believe in that yourself, alright? I'm just saying. Yay, gets the cone taken off. Woohoo! No more cone of shame. Listen, Gemma, you may not believe it right now, but if other people see that in you, then maybe you should accept that That's just fine, you know? It's okay to accept a compliment every once in a while. That's not a problem. Look, people love you, people care about you, and people want to see you be your best. Yeah, there are times we're going to be down. I've had my more than share of that. But, you know what? We see if we could put our best foot forward and we keep walking forward every day, things turn out to be okay. That I can tell you from experience. Yeah, I would imagine so. The poor puppy. Whoa, it's James Hodges raid. Holy smokes. Oh, James, my buddy, my pal. How you doing, my friend? It's James. James is a good friend of the channel, 100%. Hello, James. Hello, Jade. How you guys doing today? Everyone's absolutely fantastic. James, how are you, my friend? I hope you're doing really well. Hopefully things have been absolutely fantastic. You've been better? Be honest? Oh no, Jade. Is it work? Is it just the day's kind of bleh? What's going on? Hopefully things will be better, Jade. 100%. You know what? The day is new, okay? It is 12:03 a.m. where you live, Jade. 12:03. It is a new day. It is a fresh start. It is a clean slate. It is better. Yeah, just a rough couple of days. You know what? There can be a rough couple of days, but there's positivity on the horizon, Jade. All right? I can guarantee that. Although you've entered in a math class, doesn't mean that everything has to be so bad. I had your vaccine on Saturday, but worse for wear. Yeah, that's gonna happen, and that too will pass. When I had my vaccine, felt pretty rough. Okay, I ain't gonna lie. It was a really rough go for the second vaccine was a rough go, but I got better. It took me about a week to finally get up to a full 100%. Katie, hello! How we doing? Hopefully you're doing absolutely fantastic. Oh, that's okay. It's not a problem. You're lurking. That's cool. Katie! Hello! No, I think it's great that all of you came out there. James, I'm sorry I missed the stream today. Apologies about that. James, how's Rachel, by the way? Hopefully Rach is doing good. This other stuff, hey, that's okay. I don't need you to go into the other stuff here. Let's focus on what will make it more positive. She's all good. Excellent. 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 So I gotta ask James, when are you gonna put a ring on it? That's the question. All right. You're a young, strapping lad in comparison to my age. You can do it, James. One 100%. Look, I know whatever you're going to be doing there in the future, James, you know I wish you the best of success. For you and Rach. And that's always true. You know, it's a, well, you know, we're always here to support you, or I'm here to support everybody here that's in chat here today to be the best person that they can be. If you get out of the stream here today and you're a better person than when you came in, then that is exactly what I set out to do. And the same thing applies to my class. We're going to be the naughty kids in the back of the class? Well, if I wasn't one of them, then I would totally understand. Then I wouldn't understand, but I was. I wasn't a naughty kid, but I was pretty quiet. usually kept to myself, to be honest. Used to be a pretty... Oh, I appreciate that, Katie. Thank you. Thank you very much. That's super kind of you to say. Hey, there's a lot of love in this stream, okay? Everybody here in the class and whatnot, wonderful people. Absolutely wonderful. All right, we got to do some intros here, and then we got to get started, because that's how it's got to roll. All right, let's go ahead and do this here, and let's give it a shot, right? You ever want to know how things are actually done? Today is a good day to actually join my class, because we talk about optimization today. So very important stuff, okay? You ever talk about why packages are made the way they are? You know, you ever open up a package, anybody, and you always wondered why the packaging is so weird, or why it's done in a very particular way? Well, it actually uses calculus and cost and optimization in order to actually necessitate that. All right. Well, let's go ahead and do some intros, and let's get started. Okay, let's get started today. Welcome back to Monday. Hope a nice weekend. All right. So today, ladies and gentlemen, today we're going to do, as I just mentioned here, optimization. But let's talk about what we did last time. Last time we talked about absolute extrema. All right, we talked about absolute max and absolute min. That's what was on the docket here for last time. Today, we're going to go ahead and talk about how to find absolute max or absolute min in the form of word problems. All right. I know everybody is really looking forward to word problems. All right, 1000%. But let's go to the big board. Let's talk about word problems. Let's talk about how to do, say, section 4.5, which is the last section of chapter 4. All right, big board time. Wham. Straight to the face. All right, here we go. This will be question 2 from the handout here. And go ahead and met this out. Ooh. Oh, that was turn this up a bit. Need to turn that down. Sec. There we go. All right, I got it. All right, I got it. Trying to navigate my stuff here. All right. So let's talk about what we have here. So number 2, how can we maximize or minimize using derivatives? So the one thing to remember here is it's all about to remember that you need to set up your equations first based on the word problem, and then find the absolute max or min to figure out the optimization based on what you want to find. All right, let's talk about how this actually occurs. And of course, if you have any questions, feel free to ask. 100%. All right, let's do this. Let's do this stuff because all right, so what I need to do is I need to minimize Discord here. I need to get my thing. Here we go. Perfect. All right. All right. So let's talk about say an area. All right. So we're gonna start off with number 3 right here. I think you're gonna head off to sleep. I was gonna stay, but I just realized the time and it's made me tired. I'm sorry about that. I'm gonna go get some sleep. I'm so sorry. Andy will be on late, like a few good hours. Okay. Hopefully Andy's doing well. I need to talk with him. I haven't talked with him in a while. All right, so let's look at number 3. I know what time it is. I know it's 6 hours ahead. Yes, I'm aware. I'm aware it's 12:10 in the morning. I'm just saying, you know what? I mean, listen, I can stay up late too. I'm an adult. Okay? Just saying. I know you're 6 hours ahead. I know you got things to do in the morning. Okay, I know. No. I know math is not the most exciting thing to do at 12:10 and 12:10 right after midnight. Hopefully he's okay. All right, so let's look at number 3. Number 3 is a packaging problem. So by cutting away identical squares from each corner of a rectangular piece of cardboard and folding up the resulting flaps, an open box may be made. If the cardboard is 15 inches long and 7 inches wide, find the dimensions in inches of the box that will yield the maximum volume. Okay. Okay, so here's what we're going to do. Let's talk about how we can go ahead and find out the answer to this problem. Alrighty. Now I do have the answer right here, but the question is, how do you magically come up with those answers? How does it actually happen? Let's find out. Da, 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 da. Okay, so what we want to have happen here is what's the most important part? It's about setting up this problem here appropriately in order to actually optimize or maximize. Again, what we want to do is we want the maximum volume. So let's think about what volume is here first and foremost when it comes to a box. All right, so can anybody answer me here? What is the volume of a box? What is the volume of a box? What's the formula for that? Can anybody tell me here, what is the volume of a box? What do you guys think? Base times width times height. All right, so length times width times height is correct, Nick. Good. We'll just take length instead of base, but I know what you meant there. All right. So length times width times height. Now, I agree with that. I'm going to have to move this up a bit. There we go. All right. So here we got length and width and height. No problem. That's okay. Well, I'm here to help. All right. Now the question is, hey, we need to take a look at this particular box and how we cut this up. Now, as you can see here, we cut away identical squares from each corner of a rectangular piece of cardboard and fold up the resulting flaps. Well, exactly what does that look like? Well, here's how cardboard boxes are made, essentially, an open box anyway, is we have a rectangular piece of cardboard, all right? And in this case here, we have 15 inches long on the bottom and 7 inches wide on the sides, all right? And we don't know how much we have to cut away on the edges, but we do know that specifically they have to be identical squares. So because they have to be identical squares, they're going to be cut out like this. So we got some random identical squares on each of the corners that we need to cut out so we can fold the resulting thing up. Okay, so here are our resulting corners that we have here. Now, specifically here, what we need to do is just define whatever these cuts are going to be. We don't know how much we have to cut from each side, but because it's a square, they have to be the same length of cut regardless. So we're just going to call that X. Because we don't know exactly how much we're cutting, we're just trying to find out how much we need to cut in order to get the maximum volume here based on these dimensions we're given. So these are going to be X and X and X and X, right? The reason why they have to be X again, because it's a square. All right. So we have that down, no problem. Fine. Now, the real question is, let's talk about the length, width, and height if we cut out these squares, okay? So let's break it down one at a time. Let's take a look at the length here. What is the length of this box? So you can visualize what's going to happen here. If you cut here at each of these, dotted lines, these perforations, if you want to call it that, what we're effectively doing is the length of this box is going to be from here all the way over to here. Okay, that's the length of this box, okay, in red. All right, if you want the width of this box, the width of this box here is going to be here. Let's put that in black. From here all the way up to here. So can anybody tell me here, just looking at the picture, how can we express the length of the box? How can we express the length of the box? What would be appropriate here? Well, Yosin, that's correct for the width of the box. So I will say the width of the box here is correct. All right. So you catch me a little bit up there. The width here is 7 minus 2x. And Elizabeth says the length is 15 minus 2x. Yes, okay, good. Got that a little bit backwards, but that's fine. Either way, you're fine. Again, the reason why it's 2x is because you're taking 1x away from here and 1x away from here. So you actually are taking away 2x from the length of this box. All right, so 15 minus 2x because of this x and this x. And then 15 minus 2x again because of the other two x's. So 7 minus 2x, sorry, for the width. So before I move forward here to do the next part, are there any questions about that? Does everybody see how we got the length and width here? That's one of the most important parts here. I want to be sure everybody understands how we got that. Nick, do you have any questions about that? I hope that's pretty clear for you about where we got these two guys. Got it so far? Okay. Good, good, good. Okay. Now let's talk about the height, because that's the last part of the formula. So the height here is going to be specifically x. And again, the reason why it's x is because we cut these flaps specifically x inches. So again, it's going to we cut the squares out from the each corner, and then we just flip it up like so to make an open box, and then tape the edges together, whatever. So, all right. So, but that's going to be of height x, since that is the cut. Okay. Now, if we put this together based on what was said earlier about the volume, all right. So actually, let me move this over to this side. Actually, no. Actually, you know what? I could just make it the whole thing. Now that I think about it. All right. Let's go ahead and put all the pieces together here. And let's see what we get. All right. Got that second wind. All right. So here, our volume here is 15 minus 2x times 7 minus 2x times x. Okay, so that's the length, width, and height. Okay. Now, one of the tricks into optimizing problems is going to come down to this part right here. The trick really comes down to the fact that we want everything in one variable. So I do want to actually stress that here because it will make the subsequent problems significantly easier if we understand that. We want everything in one variable. Okay. This is the big trick into doing these optimizations. All right. This will become more apparent when we do the next problem here. But in this case, it's all in terms of x, as you can clearly see there. Okay. Now what we want to do is we want to go ahead and multiply all of this stuff together. Now, admittingly, that looks pretty ugly, but let's just go slow, one at a time, and we should be able to at least put together an answer. All right, so what I'll do is I'll multiply the x first inside, just distribute that x. So I'm just going to have 7x minus 2x squared. And I'll just go ahead and FOIL this out. and we're just going to see what we get. So if we FOIL this out here, we get 15 times 7x. That's 105x. Here I have 15 times minus 2x. That's minus 30x squared. Here I have minus 2x times 7x. That's minus 14x squared. All right, and I have here minus 2x times negative 2x squared. That's plus 4x cubed. All right, so this is our volume that we have here so far. Okay, any questions about that so far? I hope everybody saw where I came up with those numbers and how we went ahead and FOILed it out. Questions so far, anybody? No? Okay. No problem, no problem. Let's go ahead and take a look here at the next part then. So let's go ahead and clean this up a little bit. Again, just combining our like terms. We only have two of them. So minus 30 minus 14, that's minus 44x squared plus 4x cubed. All right. So the next part here that we have to do is, what are we going to do with this equation? How does this lead to optimization of some kind? Do you put things in descending degree? Yeah, it doesn't really matter because of what we'll do next, and then we can put it in descending degree after that. So, you know, it's fine. I was selling Katie a fan. I thought you were already a fan of Andy's. I thought that's the fan that you were selling. Okay. So the next part that we're going to do here is talking about what we discussed here last time. And that's correct, Yosin. That's exactly what we're going to do. The last time we talked about absolute max and absolute min. In this case here, we want to maximize the volume of the box. So in order for us to do that, just like we did absolute max, absolute min last time, what we want to do is take the first derivative of the function that we just found here for volume, and then we go ahead and set that equal to 0 and then see what we get for x. So that's really the second trick here that we need to do, is we're going to approach it the same exact way that we did here last time, last week. So I just want to point out that's the plan here. So second trick here is find the first derivative and set it equal to 0, solve for x. Okay. Okay, so finding the derivative here is fairly simple. So if we do the derivative here, that's going to be 105 minus 88x plus 12x squared. Now, if it helps, you can write this in descending order, as was pointed out here. So you can write this as 12x squared minus 88x plus 105. Okay. All right. So that's what we have here after the first derivative. Now, all we're going to do here is set this guy equal to 0 and solve for x. All right. So what we need to do next is to factor this out. Or you can use the quadratic formula. Either way, you're going to end up with two answers. So let's see if we can factor it out at least, and I'll see what we're working with. All right. So the best way to factor this out, if you can, if you're not sure about how to do the quadratic formula, is, let's go ahead and use the calculator for this. Busting out the calculator. All right. So in order for us to calculate this out, what we could do is the AC method here. So the AC method, we could take 12 times 105. So that's 1260. So the AC method says, okay, take 12 times 105. That'll be 1260. So what we need to do is to find two numbers that multiply to 1260 and add up to minus 88. Now there are a lot of possibilities you can take here, but all I do is do a little trial and error. So you could write down the possible combinations here of 1 and 1260, for example. That doesn't work. You can take 2 and 630. That doesn't work. And you could keep going down the line here. So for example, you could try, again, 1210 and 126, and you'll find out that doesn't equal to minus 88 ever. So I look down the line here. It says, okay, well, I could take 1260 divided by 20, and I say, oh, that's close. I get 20 and 63. Fortunately, that doesn't work because 20 plus 63 would be 83, not 88. So I take a notch below. Take 1260 divided by, let's try 18 because 19 is usually awkward. And 18 and 70. There you go. So this is going to be our winning combination here. We have minus 18 and minus 70 would be our two numbers that satisfy that. All right. Good old AC method. All right. So we can rewrite this equation as 12x squared minus 18x minus 70x plus 105. 0. All right. So let's see what we get here. Let's find out. So if we factor this part out, we get 6x. We're left with 2x minus 3. Bring down this negative sign. We could actually factor out a 70 and a 105. 35 is in common between both of those. Okay, Gemma, you have yourself a good one, okay? That leaves you also with 2x minus 3. So you're going to end up with two possibilities. We'll end up with 6x minus 35 times 2x minus 3. If we factor that out appropriately. Now remember, some of them don't factor as nicely as what you see here on screen. You may actually end up having to use the quadratic formula, but this one here actually does factor rather nice, so it is what it is. All right. So if we set both of these equal to 0, then in this first case here, we have x is equal to 35 over 6. And in the second case, 2x minus 3 is equal to 0. And here we get x is equal to 3 halves. Okay. All right. Okay, so before we move any further here, are there any questions about how I found these two values here for x? Let's at least, probably should slow it down right there, just in case. But are there any questions about how I found those two numbers here? No? Wait for see if Yosin or Emma or Nick have any questions that they would like to ask. Ackle would like to ask me questions, so. Why did you do the steps in red again? Again, that was to factor that was to factor the resulting derivative, because I needed to set, so what I needed to do here, Nick, was I needed to set the derivative here equal to 0. So I needed to factor it out in order to solve for x. That's why I went ahead and did those steps in red, is to just be able to factor it out. I could have gone a different direction there, admittingly, Nick, and I could have done the quadratic formula. But I find that with bigger numbers, the quadratic formula tends to be a little bit harder. So I decided to see if I could factor it into nicer numbers first. So I was able to do that successfully here in this case. But yeah, I'm just kind of letting you know that's essentially what I did there. So. Are there, I hope that made sense there, so. Now, anyone else before I move forward? Okay, we'll move forward unless we have another question, so that's fine. Okay, now I want to bring your attention to one thing. In this case, oh, can I clarify how I got the 70? That's fair. So I just tried, basically, I did a little trial and error there, Emma. Is what I did is I did combinations to get me 1260. So on the calculator here, I just went ahead and just kind of went down the line. I did 1260 divided by 2, and I could see, does 2 and 630 add up to like 88? The answer is no. Then I could try 1260 divided by 3. You know, if I get a nice number there, then I get 3 and 420. And I say, well, if does 3 and 420 equal 88? Well, the answer is no. And I can keep going down the line until I get two numbers that can realistically add up to 88. So 4 and 315, definitely not. I could try 5. 5 and 252 doesn't equal to 88. I could try 6. 6 and 210 doesn't really go well for 88. I could try 7. 7 and 180, that doesn't really go very well to get 88. 1260, a lot of numbers divide 1260. It could go 8. 8 doesn't even divide 1260 evenly, so that's automatically out. I could try 9. 9 and 140, does that work? No. Okay, so you could keep going down the line here and just trying to get a combination of numbers where you can realistically add them together and get, in this case, 18 and 70. So eventually you do a little enough of trial and error, and you're going to get 18 and 70 here as the combination to get 88. And again, if this is too much, which is okay because the numbers are rather big, then go ahead and do the quadratic formula, which could take you a little bit more time to do, but again, that's also plausible as well. No problem. Anything else? All right. If there are no more questions, we're going to go ahead and move forward here. Again, just stop me if you do. All right. So let's take a look at our two answers that we just found here. Okay, we effectively found two answers for x. We found 35 over 6, and we found 3 over 2. Now, realistically, let's look at each of these, you know, as a separate guy for just a second. If we do 35 over 6 as a decimal, that's 5.8, you know, 3 to 3 repeating, whatever. And 3 halves here is just a simple 1.5. So all right, I don't think there's anything wrong with that. So here we have 1.5, and then, you know, here you have 5 and actually I should say, yeah, 5 and 5/6, so something akin to that. So 5.83 repeating. All right. Now, I am going to write the decimals down here for a reason, okay? I am going to write them down for a reason here, at least in this instance. And that is simply because one of these answers here will not work, okay? So one of these answers here is not a good answer, all right? Let's at least discuss why that can happen here. Now, what do we call these type of answers here? These type of answers do have a name that goes along with them. So I'll go ahead and at least mark that down here on the handout here. So this is basically what we like to call an extraneous solution. So an extraneous solution is basically a solution that you find in which that number does not work in the original problem. Okay, so basically we want to throw those answers away and keep the ones that do work in our original problem. So how do we know which one is going to be our winner between, 5.83 repeating and 1.5? They're both positive numbers, so you're probably saying, okay, well, which one does it have to be? Let's go back to our original problem. Our original problem all the way at the beginning here was going to be this, okay, our volume equation, right? So 15 minus 2x, 7 minus 2x, and times the x there. It solves the function but does not fit within the criteria for the application. That's correct, Hunter. Exactly. So I'm going to look at the... good to see you again, by the way. So I'm going to go ahead and use the original function here of 15 minus 2x and 7 minus 2x and x. So if I try the first one here, let's say I try the first one of 5.83 or 35 over 6. Let's see what happens with that. Okay, so here's all I'm going to do here. So I'm just going to showcase that off here. So I need to zoom out there. A little bit more of a canvas here. All right. So let's try 15 minus 2 times 5.83 repeating. Let's see what happens there. Let's see what happens with 7 minus 2 times 5.83 repeating. Okay, so we're just going to check the volume here, all right? And we're just going to go ahead and plug it in, all right? So let's take a look. Let's just try the first one here. We got 15 minus 2 times 5.83 repeating. Well, let's just put, I'll just put, don't matter. All right. All right, so we get a positive result for that. That's fine. It's like 3 1/3. Okay, whatever. We'll multiply that. We'll go ahead and see. We'll just put in 3 1/3 here. That's what essentially it equals. All right. Normally I don't use mixed numbers, but I guess we'll make an exception for this. Next, we'll have 7 minus 2 times 5.83 repeating. All right, so here we get minus 4 here we get negative 4 2/3. And here we get 5.83, so again, 35 over 6. Okay, now here's the problem. The problem comes down to this, is that you have a negative, essentially you have a negative width. That doesn't make any sense, okay? This, negative 4 2/3, whatever it is, this makes absolutely no sense. You cannot have a negative width. I mean, I haven't seen anything with a negative width before. So, yeah. So basically, 35 over 6 is what we call an extraneous solution. Again, you would effectively throw this solution out, because as you can see here, we plugged it into the original problem. We got a negative value for our width. And that's pretty bad. We don't want that. Okay, that should be right out. All right. However, the 1.5 or 3/2 should definitely work in its stead. So that should be our effective solution at the end of the day, is going to be this 3/2 here. So let's go ahead and figure out what our length, width, and height are going to be. So since we know 3/2 got to be our winner by process of elimination. So 15 minus 2 times 3/2. If you do that out, that's going to be, you can cancel the 2's. 15 minus 3 is 12. If we do 7 minus 2 times 3/2, 2's cancel out. 7 minus 3, which is 4. And of course, we have our 3/2 there, or 1.5 for our height. So length, width, and height. And if all you need to do is find out the maximum volume, just go ahead and multiply these together. The maximum volume here will be 12 times 4 times 1.5. All right, and so this will be 72. All right, so that's where we can get these answers here in this instance. Let me go ahead and so that's where you get these answers that you see here on the screen. The smallest value here being 1.5, then 4, and then 12. And then those are your 3 answers there. And the maximum volume you can get is 72 cubic inches. All right. It takes a little bit to explain there, but again, like I said in the answer to this question here, it's all about the setup. And then once you set it up, it's really not as bad as it may seem. Again, though, remember the 2 tricks. We want everything in one variable, and we set that first derivative equal to 0, solve for x or whatever variable we have. So, okay, are there any questions about that? I hope that made it crystal clear about what the result should be. It just takes a little bit of time to actually explain things through. Let me know when you guys have that down, and I'll move forward with the next example. So Nick, Elizabeth, Yosin, hope everybody's okay. Hunter, hopefully you're all right with that. I think Hunter pretty good with this stuff. Hunter's probably smarter than I am when it comes to math. So. Makes sense. Okay. That's the easy one, by the way. Just gonna let you know. That's the easy one. Got a couple of toughies, but with our 2 tips we have here, it should hopefully we'll make shorter work of them. How we doing, Nick? Hopefully it'll be easy. If that's the easy one, I'm lost. What question do you have there, Nick? The reason why it's the easy one is because of the fact that everything was in terms of x. So all right. All right, so I'm going to move forward here unless anybody has any more questions about that. All right, let's move to the next one here. All right, we're going to go ahead and do this is number 7. All right, so let's do number 7. Number 7 is a book design. All right, so here we see the answer. That's all nice and good. of course, we have to be able to come up with that answer. So, a book designer has decided. I'm gonna have to jump off. Phone's at 1%. Can you use my? Oh, yeah, that'd be helpful. Good night, Katie. All right. A book designer has decided that the pages of a book should have 1-inch margins at the top and bottom, and half-inch margins on the sides. So, as you can see there on the picture. She further stipulated that each page should have an area of 18 square inches, seeing the accompanying figure. Determine the page dimensions that will result in the maximum printed area on the page. Alright, so here we found X and Y. We know what the answers are, but once again here, let's talk about exactly what it wants us to do. The key part here is that each part of the page, we want the maximum printed area on the page. Alright, that's what we want here. Alright, so let's take a good look at the picture here. So take a long, hard look at the picture. So that's really what it's going to be about, is setting up that particular problem. So let's look at the area here first. So what is the area of the printed portion you see there? So the part that you see in or with the blue box around it. What would be the area of that printed portion? What would be our length, and what would be our width here of that printed portion? What would you guys think? How would we set that up in terms of the X and Y we see there on the page? What do you guys think? We're shaving off a 1/2 inch on both sides, okay? That's what we're doing. For the X part, we're shaving off 1/2 inch on both sides for the margins. On the Y side, we're shaving off 1 inch on the top and the bottom there. So how can we set up the the printed portion here? That's the first question we have to ask. So that blue box there, how can we put that in terms of X and Y? All right, so this is a pretty important question, so why we're talking about this here. So let's take a look at our length and our width. What's the length of the printed portion here? What's the length of the printed portion? Anybody tell me here, what's the length of this printed portion? Okay. I could wait here a little bit. That's fine. X minus 1 and Y minus 2? That's correct. Right? You have X minus, you're shaving off a 1/2 from each side. That's right. So the length in print here is going to be X minus 1 because you're shaving off a full inch from each side. And the width for the print here is going to be Y minus 2 because you're shaving off a 1 inch from both the top and bottom. Good. That's correct. So let's start off with that. All right. In effect, we're essentially trying to figure out what we're trying to maximize here. So we know that the maximum printed area here has to be X minus 1 and Y minus 2, whatever those inches are. Fine. We also know one other thing, though. Let's talk about this next part here. That the area of each page, no matter what margins are on there or whatever, it needs to be specifically 18 square inches. So what we're going to do here next is also going to be very important. We're going to take that x and we're going to multiply that by y, and we're going to set that equal to 18. Okay, so x times y equals 18. So we absolutely need to have that here, okay? Because that is going to be the area of each individual page, not the printed area, just the area of each page in general. Okay, so before we move forward here, are there any questions? Okay. Now you're probably wondering, you're like, well, where are you going to go with this? Well, let's think back to our trick from what we talked about here before. Our trick says we need to put everything in terms of one variable. And in this case, we can put everything in terms of one variable. You're probably saying, how? How can we put everything in terms of one variable? I got two equations here and I have no idea what I'm doing. I said, that's fair. I don't mind if you say that. That's perfectly fine. So in order for us to go ahead and do that here, what we are going to do here specifically is to solve for one of the variables here, either x or y, in this second equation. Then we'll substitute that into the first equation. So we're going to play a little substitution game. So I'll let you guys decide. Which one do you want me to do? Do you want me to solve for x, or do you want me to solve for y in this equation of xy equals 18? You tell me. Should I? It doesn't matter which one I solve for. I'm going to get the same answer. So same answers for either one. So do you want me to solve for x, or do you want me to solve for y? You guys pick. I don't mind either way. You guys pick them. I'll wait. That's fine. You want me to solve for y? Okay. So if we solve for y here, all we're going to do is we're just going to take this x. We'll just divide by x on both sides. Fine. So here we have our equation here of y is equal to 18 over x. So all I'm going to do here is take this 18 over x, and I'm just going to go ahead and plug it right in to where that is in that first equation. That's what I want to do, because that ensures I get everything in terms of x, which is just fine. All right, that's all we're looking for here. If we put everything in terms of one of those two variables, then we can go ahead and do the same thing we just did in the last problem and solve for x. You take the derivative, solve for x, and then we can solve it for y afterward. So here, let's go ahead and write down what we have here. We have x minus 1 and 18 over x minus 2. Let's FOIL this out. So we have x times 18 over x. Come back to that. We have x times negative 2, so that's minus 2x. Fine. Here we have minus 1 times 18 over x, so minus 1 times 18 over x, that's fine. And here we have minus 1 times minus 2, that's plus 2. Okay, great. So, no problems there. Easy peasy. Alrighty. Now, the question is, what do we do next? Okay, well, that isn't too bad. These x's will conveniently cancel, so that's fine. We do want that to happen here specifically. So here we have 18 minus 2x. We have minus 18 times x to the... I'm going to rewrite this 18 times x to the minus 1, because that's what we have here as 18 over x. And then plus 2. So here we have 20 minus 2x minus 18 times x to the minus 1. Okay. So this is what we have here so far. All right. All right. No problem. All right. Now that we have that, let's go ahead and see what we get next. So what we get next here is we go ahead and take the derivative of this particular function. All right, so taking the derivative of this function here, again, if we take the derivative of 20, that's going to be 0, so that wipes out. 2x, that's going to be minus 2. Okay. And then here we have plus 18x to the minus 2 power. Okay. So that's what we have here so far. Okay, so the question is, what do we do next? Well, I'm going to go ahead and rewrite this just one more time. Let's just make it easier on ourselves. Take minus 2 plus 18 over x squared. I'm just going to rewrite it. Not doing anything fancy. I'm also going to set this equal to 0. Okay, because we have to solve for this at the end of the day. Okay, we set this equal to 0. All right. Okay, questions so far? Any questions? Hopefully not too shabby. All right, let me rewrite this over here. All right, so the next thing we're going to do here, no? Okay. As long as you guys can follow along, then that's okay. But again, feel free to stop me whenever. I don't mind. All right, so here we're going to add 2 to both sides. Again, we're just going to manipulate this. Get 18 over x squared equals 2. All right, so the question is, how do we go ahead and solve for x? We're going to multiply by x squared on both sides. So we have 18 equals 2x squared. We can divide by 2 on both sides. Here we get 9 is equal to x squared. Take the square root of both sides. Then finally we get x is equal to 3 and minus 3. Okay. We got two answers here for x. Now, really quick here, which answer does not make any sense? Does 3 not make any sense? Or does minus 3 not make any sense? Which answer makes no sense? Which answer can we throw away? Is it going to be the 3, or is it going to be the minus 3? Yeah, the minus 3 doesn't make any sense. We can't have a negative width or a negative length for a page. That makes absolutely no sense. So we're just going to automatically drop that out. So our answer here has to be 3 for x. Okay, so that's a given. We already found one answer here, which is 3. Fine. Okay. Now we just have to solve for y. But we already do have y here because y is equal to 18 over x. So if we just use that, go ahead and plop it right in. We already solved for x, 18 divided by 3. So y is equal to 6. All right, so in this case here, y is equal to 6, and x here is equal to 3. And if we take a look back at our answer here on the homework, anytime, you can see here that in this case that indeed is the case here. X is 3 and y is 6, our final answer. All right, so we have that there and ready to go. Okay, questions about that? Would you guys like to take a short break? I know this is a lot to take in, so I tried to go as slow as possible here, though, so it's not super overwhelming. But I know that this is a lot to take in. So be sure that you have your notes available and whatnot. Okay? Yes? Okay. Let's take a 10-minute break, okay? We'll come back at 7:11. Right? So, yeah, we'll come back at 7:11 because it just sounds cool that way. Um, so there you go. Let me hold up my stereotypical namesake, and yeah, we'll come back at that point. All right. We'll come back. All right, guys. You guys have questions, but let's just take a chill, take a chill pill here. No problem, guys. Back. Can you hear me now? Is that better? Am I good? Yes, no? Alright, I'm good? I'm muted or no? I'm so confused. Okay, yes, I'm muted. Or no, I'm not muted. Or oh, okay, yes, you can hear. Okay. I'm so sorry. Okay. Yeah, so this is yes, you're muted. We can't hear. I mean, it started with you saying I was muted, so I was like, muted, yes. And I'm like, oh, okay. Alright, sorry. Sorry. Just let me, hey, Hunter, let me be an old man for just a second. Shush! uh, all right, yeah. So there's not like a ton of business type of applications. I won't lie. It's like I was saying, even though I was muted, like it's a smattering of like a lot of different applications from a lot of different fields. If there you go. I'd be surprised if you were much older than me, just at all. I don't know how old are you, Hunter? How old do you think I am? That's the real question. I'm gonna put it to you. He's like, how old are you? And then how old do you think I am? Is that a trick question? I don't know. Depends how old you think I am. I mean, I get a lot of answers. I get a lot of answers about how old do you think I am. I'm a third of 100. Okay? But how old do you think I am? You're gonna be 33, maybe turning 34 this year. Okay. How old do you think I am, Hunter? Or anyone else? Anybody else? You could put a guess. Put a guess in your chat. How old do you think I am? I get a my age plus or minus 3 years. Nothing to be ashamed about, trust me. Nothing to be ashamed about. Not at all. Oh, that's my prediction. You was gonna guess 30. 30! Just 30 years old. Wow. I'm so honored to be 30. I'm so honored, man. I'm super stoked to be 30 again. Now, if you could guess, in reality, I am not 30 years old. This is how old I am, ladies and gentlemen. That's how old I am. Although I don't look like it. But, yeah. That's me. I was born in 1979. I'll be 42 this year, actually. Of all things. But, yeah, I get 30, you know. If I shave my beard, it gets even younger. I ain't gonna lie. It works out even better when I shave my beard. You guys are like, once you are really assured you, is there much of a difference? It depends from person to person. What are your youth secrets? Asking as an 18-year-old for the future. I think you're already doing absolutely wonderful. If there's one thing that I kind of follow is I've been through a look. All right, dead serious, dead ass here for just a second. I've been through a lot of trials and tribulations, like many other people have. But one thing that I've learned over time is you just go less stress, less mess. That's a principle that I follow here. That when I took out the stress from my life, it got a lot better. It got a lot better. For genetics, your genetics may have something to do with it. I don't know. My mom and dad, you know, they're up there in age. My mom was always younger looking, I suppose. Maybe I got that from her. My dad, not so much. Hey, my mom, yeah. Indoor seclusion, yeah. Indoor seclusion has a lot to do with it. But no, I mean, seriously, I mean, It's like kind of changing your mentality. Like that really helped me out a lot. When you put a lot of stress on your body or you put a lot of stress on your mind, it really ages you much faster than maybe what you were hoping that it, maybe what you intended to be. And genuinely, none I ever guessed you were any older than 30. Yeah, when I started at Elgin, I was actually 30. I was 30 when I started Elgin, actually. Yeah, over 10 years ago now. So not a lot of people make that connection because I look super young or something like that. So that's where I work. I work at a community college there, Hunter. So that's one of my 2 jobs that I work. We're in Illinois here, Hunter. Oh yeah, there are other states that have Elgins. I'm pretty sure. Just like there's a ton of states that have Springfields. To be fair. And the only other city that I recall very much that started with the letter E was Eagan, like Eagan, Minnesota, right next to St. Paul. Or right close to St. Paul, I should say. It's a suburb, I should say. Growing up in the Bible Belt, one county, 40 different church streets, and the church rows as church lanes. Yeah, I can't. Well, I ain't gonna lie. Being a pizza driver, having that many church lanes is gonna drive you bananas. Why don't they just call it like the name of the church? You know, like First Baptist Church Lane or something like that. You know, that would make it easy. And then like, okay, I have to go to First Baptist Church, and then be like, perfect. I know exactly where that is. I don't have to name it Church Lane. I could just name it exactly after the church, and be like, cool. I'm down with that. That's okay. Look, those things are gonna happen. Not everybody's gonna be, not everybody is gonna be the brightest bunch. But you know what? People have their own positive contributions in their own way. So just understand that you build a community, but it takes more than one person to build a solid community. So you have to be diplomatic, though. If you don't, then really you'll bring the community down. You diplomatically kind of take out the pieces that don't work, rotate in some pieces that do work. Always got to be diplomatic in that regard. There is one thing, though, that I don't do diplomatically, I should say, to be as terse as possible, and that's accountability. That's the first thing that I have to take in mind. Accountability is the first and foremost thing. If I make a mistake, I have to be held accountable to that mistake, and I have to make up for that mistake. That's the most important thing to me. And if I'm accountable for myself, that means that I hold other people accountable as well. But it has to start with me, and then I can project it onto others. So that's me. So yeah. So if I don't hold myself accountable, well then that's not fair to anybody else. You can't preach to other people if you don't hold yourself accountable. That's the first and foremost thing. Recognize your mistakes, work on those mistakes, build yourself up, and then you can hold others accountable for making similar mistakes, or again, help them hopefully overcome those issues that they have. Well, yeah, that's easy. You can easily point fingers, but the only finger that you should point first and foremost is always right there. And there are times where I didn't have that. I didn't hold myself accountable, and I paid a price for that. I'm going to hold myself accountable first, and then and then other people can listen to what I have to say, because there are mistakes I've been made, and then I have to make up for those mistakes and learning from those mistakes. That's the most important part. And then we can all build each other up together. That's so important. Well, I'm not here to get votes. I'm just here to do what's right for the community. Getting votes is one thing, but doing right by the community should be something more than just getting votes. I can talk, anybody can talk 2 ways out of Sunday. It's just a matter of, how far down the rabbit hole you want to go in terms of your hypocrisy. So, that's right. I'm here to help find solutions, not just exacerbate problems. However, in math, I give problems, of course, like this next one. Let's do that. I'm going to show off this next problem. Everybody's going to hate me. So let's do it, though. All right. So the next problem, and the last example we're going to do here today, is going to be number 8. Parcel post regulations. All right. So I'm going to bring this up on the big screen. That's all right. Oh, Nightbot's got that automatic thing I have scheduled. Anyway, postal regulations specify that a parcel sent by priority mail may have a combined length and girth of no more than 60 inches. Find the dimensions of the cylindrical package of greatest volume that may be sent via priority mail. Hint: the length plus the girth is 2 pi r plus L. Now, this is incredibly important, at least this hint. This hint is going to be super helpful for what we want to do. But what we want to do here specifically is, again, it all comes down to the setup of the problem. So let's go ahead and take a gander about how we can do that. All right. Let's start fresh and anew. And let's see what we can get here for this last example for the day. I wanted to take this last example a little bit easier on you guys, since I know the first two were a lot to take in. So let's just take it nice and slow, and we'll work through it together, okay? Okay, first and foremost here is that the length plus the girth. Now they give that to us right away. So 2 pi r plus L is the length plus the girth. And according to the problem here, it has to be no more than 60 inches. So what we're going to do here is we're going to set that equal to 60. Okay. Back to this here. Okay. So we have that. However, remember what we're trying to find. We're trying to maximize volume here for this cylindrical package. All right. So let's take a look at what the formula is. What's the volume of a cylinder? Anybody remember here the volume of a cylinder? Okay. We're gonna L pi r squared equals. Oh, okay. Not quite there. Not exactly, Hunter. Not exactly for this case. We're gonna put these pieces together though, so you'll understand where we're getting here. But we need the volume of the cylinder first before we can put those pieces together. Does anybody remember what was the volume of a cylinder? Anybody remember what that was? Because that's what we're trying to find here. Oh, if that's what you're saying, Hunter, then that would be correct. Yes. If you're referencing volume, then that's correct. I'll have them look that up though, see if they tell me the same thing. What's the volume of a cylinder, folks? Because that's what we're trying to maximize. Oh, okay. No problem. No problem. It's all good. I'll have them figure that out too, because they got to put together the pieces. All right. Emma, Elizabeth, Nick, anyone? You guys tell me what the volume of a cylinder is going to be. Again, if you're not sure, just look it up. That's perfectly fine. That's the point. Because if you don't get this part here, then the rest of the problem is not going to go very well here. So I just want to be sure that you guys understand why I'm choosing the volume of a cylinder here. So I'll wait for one of you guys' answers here. So I get pi r squared h. All right, there we go. We got it. Okay. Now in this case here, we do have pi r squared. In this case, our height here is going to be the length of the package. So I'm going to put that as L. All right, so L would replace H, since the length it would be the height of the package, or whatever you want to call it here, according to the picture. Okay. So now the question becomes is like, okay, let's do the same thing that we just did in the last problem. Now we have two equations in terms of two variables. Okay, we have L and R. Okay, and as long as we put it in terms of one variable, we can do the same exact tactic that we did before. We'll go ahead and, once we put it all in one variable, we'll put it in terms of a derivative. We'll do the derivative, we'll set it equal to 0, and solve for, whatever variable is left over. Now, in order for us to do that here, let's take a look at the first equation. So notice we have 2 pi r plus L is equal to 60. So what we're going to do here first is we're going to go ahead and subtract by 2 pi r on both sides. What this will allow us to do is we're going to have L here is equal to 60 minus 2 pi r. So all we're going to do here is we solved it in terms of one of the variables. I figured that L was the easier of the two variables. So I'm going to just go ahead and take that 60 minus 2r. I'm going to plug it into that L into the volume equation, because that's what we're trying to maximize. So what we have here next is we have pi times r squared, and then we'll substitute L, which is the 60 minus 2 pi r. Okay. We'll go ahead and distribute the pi r squared. So we're just going to get 60 pi r squared. And I'll distribute the pi r squared to the 2 pi r here. So just this distributed here and here. So we got minus 2 pi squared r to the third. I know that looks a little weird, but yes, you can leave pi squared like that, and that's perfectly fine. Okay. Any questions about that? Hopefully that makes a bit of sense about what we're doing there. This is our volume equation in terms of one variable so far. Okay, I'm going to move forward then. Okay. Again, if I'm going too fast, just let me know. So I'm going to take the derivative here of the volume equation. Again, in terms of r, that's what I want to do here. So if I take the derivative here, I get 60 pi r squared. Well, you can bring the 2 out here. I'll get 2 times 60 times pi times r. That's fine. And then here I can bring out the 3 out here. This will be 3 times 2 times pi squared times r squared. Okay. Again, pi squared is just a number, by the way. it doesn't have anything special, and it's not a variable. So I'm not going to do anything with that. So I have 120 pi times r minus 6 pi squared r squared. All right. Any questions about that? Hopefully that is a little bit clear, but I'll stop there for just a second. Any questions? Why didn't pi's exponent change too? Pi is a number, not a variable. So pi's exponent will not change. Only variables will they change. Yeah, I know that's a little misleading, but in reality, it's just because pi is just a straight up number. So, and it's easier just to not write, 6 times pi, which is some gobbledygook number. That would be a nightmare to write out every time. So if it had been a variable, the exponent would have changed. Yes, but in this case here again, everything is in terms of one variable, right, Elizabeth? Everything is in terms of r here. Once we played the substitution game there, everything was in terms of r. So that is what we wanted at the end of the day. We can't have two variables floating around. Just have to have one variable. Yes, indeed. That's true, Hunter, 100%. Okay. Any other questions before we move forward? Nope. Okay. I'm just going really slow here, so we get this down. Now, the next part here is we want to set this equal to 0. We're still going to do the same thing we did before. If we set this equal to 0, and we're going to solve for r. Now, the best way to solve for r here in this case is to go ahead and factor out that left-hand side as easy as possible. If you notice here, both parts have a pi in them, both parts have an r in them, and they both have a factor of 6. So I'm going to go ahead and factor out a 6 pi r from both terms. So what I have left over here is 20 if I divide 120 pi r by 6 pi r. And if I take away 1/6, I have 1. If I take away 1 pi, I have 1 pi left over like this. And I have 1 r left over like so. Okay. So this is what we have here so far. Factored out a 6 pi r from each of those terms, and this is what I'm left over with. Again, going to use the zero product property here. Going to go ahead and set each of those factors equal to 0 and solve for r. 6 pi r is equal to 0, and 20 minus pi r is equal to 0. So you did a differential, differential on the volume equation to get across, to get a cross section which represents the area of the circle. Well, it represents, again, it's just another representation of the volume there. That's all essentially that we did there. So many big words. uh, yeah, so all we did was just redo the volume here, and then in order to maximize said volume, that's why we went ahead and took the derivative there. That's essentially what we've done there in that case, Hunter. So we haven't done anything super fancy, I promise you. So just a re-representation and then maximizing the volume by doing a first derivative test. All right, so in this case here, r is equal to 0. There's not much going on here. 6 pi r is equal to 0. You can divide by 6 pi on both sides. And you just end up with 0. So that's fine. Okay. Now, this other part here is going to be a little bit tougher, but let's go ahead and just do this out. So probably should have done that first. So here we're going to add by pi r. So I have 20 equals pi r. I divide by pi. So here I have r is equal to 20 over pi. So, okay. So I get two answers for r here. Now the real question becomes, is that which one of these two answers does not make sense? Basically, which answer can I automatically throw away? Which answer should I throw away? We got two answers for r here, by the way. It probably is 0, right? All right. So 0 doesn't make any sense. Okay. The reason why 0 doesn't make any sense to have a 0 radius is kind of contextually just wrong. It's pretty bad. That's okay, Hunter. That's not a problem. Wouldn't V1 no longer be a volume? Again, it's just a volume rewritten in terms of a constraint. The derivative of V is no longer the volume, technically. That's true. Derivative volume would be an area. That's a good question. I'm not sure about that, actually. I'm just using a test here of using the derivative to essentially maximize my volume. So technically that would be true if you're looking at it from a 3-dimensional, 2-dimensional, 1-dimensional thing. If you're doing it like that, then yes, I suppose then you could look at it that way. Do the derivative of pi r squared, it's 2 pi r. That's true, yeah. I will say that to be the case, then that's true. If we're looking at it that way, yes. Yeah, I actually hadn't noticed that, but yeah, that's true. I hadn't thought of it that way. I'm thinking about it one case at a time, to be perfectly honest. I was thinking it kind of like, what am I trying to do? I'm trying to maximize the volume here. So what do I have to do? You know, I'm more of kind of like, in all honesty, I'm more of a reactionary kind of guy when it comes to math. Is like, what's the next step in the process based on what needs to be done? Yeah, I know. I always think in logical processes like that. I ain't gonna lie. Okay, so here we found r is equal to 20 over pi. So now the next part here, by the way, is we need to go ahead and figure out what L is. But L here is equal to 60 minus 2 pi r. So if we're going to find the length here that maximizes the volume, length here is 60 minus 2 pi r. So we're just going to go ahead and plug in r that we just found here, this 20 over pi. I'm going to see what we get here. So here we get 2 pi times 20 over pi. Now what's nice about this is that these pi's will cancel out, so that's pretty convenient. That leaves us with 60 minus 2 times 20, which is 40. So this is going to leave us with 20. So 20 is going to be our length here in this instance. Okay. So far, so good. So now the last part here that we have to do is figure out, according to our question here, let's go back to our question, is what is the maximum volume here of such a package? So I'll show you how we got the 8,000 over pi now that we have both of those answers set. So we go back to our original volume equation. All right, so our original volume equation here would be Again, pi r squared L is what we have here. So we know what r and L are. So pi r squared times L, the length. So this is specifically going to be pi times r squared, which is 20 over pi, times L, which is 20. This should be squared. So this should be pi times, and then if we square this, that's going to be 420 squared. And on the bottom here, we have pi squared times 20. Well, this pi and one of these pi's cancel. We're left with 400 times 20, which is 8,000. And then the pi here being in the denominator. There we go. That's our maximum volume, 8,000 over pi, which is our final piece of the puzzle. Okay, and there we go. We got all three answers. We got R, we got L, and the maximum volume of said package with said dimensions. Okay, any questions about that? All right, questions, questions, questions. Any questions about that? That was the last example I wanted to do, so next time will be a bit easier, I promise. But today it was like kind of going through these three examples here carefully, so. So one of the things that I recommend is to this is probably one of those videos you probably want to watch again, just to see, kind of going through the steps here very carefully, one at a time. And you'll see exactly how the steps kind of met out one step at a time. Oh, yep. Can you clarify how you found the length x minus 1? Sure, I can do that. Absolutely. So let me go back to that example there for just a moment. All right. So take a good look here at the picture here, Emma. So according to the picture here, what we have here is that we're having a 1/2 inch margin on both sides of x and then a 1 inch margin on both sides for y. So why is it x minus 1 is because you have 1/2 inch on the left and 1/2 inch on the right that you're cutting away according to what these specifications need to be. So in fact, you're taking away 1 inch from the page for your margins for the x value. For the y value, because you're taking 1 inch off from the bottom and 1 inch off from the top, you're in effect taking away 2 inches from the y dimension. All right, since that's, as you can see there in the picture, you go up and down, you're effectively taking 1 inch off the bottom and 1 inch off the top. So that's why it's y minus 2 there. And 1/2 inch from the left and 1/2 inch from the right, that effectively takes away 1 inch total overall from the x value. So that's why we get x minus 1 and y minus 2 as the dimensions of the actual printable area in this particular problem. Yeah, so one thing that's really helpful for this is that the picture is really super helpful. It'll help you see exactly how much you're taking off from both x and y. So definitely follow the picture for that. Make sure that you follow that carefully. Anything else? Nick, are you still with us? I hope I didn't melt your brain there, but my dude. This one here I admit is a little tough. So again, oh, don't worry, we're about to call it. Don't worry about it, my friend. I know you're super confused. You can certainly call soon. We're effectively done, by the way. I'm just gonna not lie. All right, it's just this one here is just calls in Discord. Yeah, you can certainly call me in Discord. I'll be there asking questions. Sure, 100%, my friend. Hey, Sammy G. Um, yeah, that is the that's the oh yeah. Sorry, my face is in the way. There we go. Are these your students? Yeah. Yeah, they are. Absolutely. Yeah, this is definitely a class, my man. Why the title is listed the way it is, I promise you. Get a grade and everything. 100, yeah. Now this is like math class on a field trip. I'm not sure what to say to that, but okay. I guess we'll roll with that. Yes, it's xy equals 18, correct. Because that's the whole part of the page there. That's right, Sammy. It's the whole page and not the printed area of the page. That's the part that people mess up on a little bit when setting it up. Then you expand and you have to substitute and then take the derivative there. Yep, that's right. You have to solve for either y or x, and xy equals 18. Substitute it in for either x or y, depending on which variable you solve for. Then take the derivative, and then solve for the remaining variable after you take the derivative, after setting it equal to 0. And there you go, bada bing, bada boom. Yay, yay. The toughest part is just, hey, hey, Froza. Hi, is this pre-calc or calc 1? Yeah, this is business calc here, so calc 1. Calc 1, just without the trigonometry there. Hope you're doing that. Hopefully you're doing well there, Froza. Calc 0.5. Algebra half. Oh my gosh. Or algebra 1.5. Man. Holy smokes. Anything else? Anything else anybody would like to ask? Please ask away. Anything you like. Just hopping to maybe some review some stuff because I'm done with math calc 1 and 2. Okay. I mean, yeah, we're almost done here for the day, to be perfectly honest. But yeah, um, if I give you anything a reminder, then hopefully it could be of some use. Hopefully, question mark. All right. Not sure what's going on with that. Why are you doing that? That's need a TA. Man, I used to be a TA way back in the day. Oh wait. Okay. All right. Okay, let me switch over to my full face cam here. Go. All right. All right. So I want to thank everybody here who has come out here to the stream today. Thank you very much. I really appreciate the time and the energy all of you decided to come out and I guess have a grand old time. Um, I gotta put some. I don't know why my thing is not doing so hot. So my interwebs connections is not like responding very well. Anyway, we'll be okay. All right. In any case, I want to thank everybody for coming on out here to the stream again. Thank you so very much. It's really well appreciated. Trust me. Thank you for all the questions and whatnot. Hopefully, you guys got along with the stuff there. Again, you can contact me via Discord, um, or again email. You guys know where to find me. All right, and so we'll end off here for today. If I can ever get some music going for the outro, that would be pretty great. But I think that YouTube is kind of borked at the moment. So, well, we'll just kind of work with that. All right. In any case, all right. Thank you very much, everybody. And as always, stay safe, stay healthy, but most importantly, stay sane. All right. Have yourself a very wonderful day. And we will see you all next time, okay? We'll see you all tomorrow, same time, same place, where we're going to go ahead and start Chapter 5, okay? So Chapter 5 is next on the agenda there. Chapter 5 is next, okay? So that is what we're going to be doing here tomorrow. We'll be switching gears here quite a bit here, doing some basic stuff here to start with, and then working with some derivatives and whatnot with some exponential functions. That's the goal here for chapter 5. So a little bit easier stuff than what we got here at the end of chapter 4. Just as a serve as a reminder here, by the way, the next test here is over both chapters 4 and 5. Okay, so I haven't quite made up the test just yet, but again, it's in progress. Chapters 4 and 5 will be the next exam. Okay, so just letting you know now before anything else happens. All right? Okay, everybody. Thanks again, everybody. Everybody, take care of yourselves, and we will see you all later. All right? Have yourself a wonderful night. Take care of yourselves. Have a great one, everyone. We'll see you later. All right. Bye. See you guys.